morning.
Good morning.
Good morning, everyone.
So thanks again for coming to the to one of the server committee tracks. This is our third in a row presentations around how we better move between 19-inch EIA standards and Open Rack standards. And pleased to announce Bill Lynn from Wiwynn to give the presentation on OCP adoption.
Good morning, everyone. Good morning. I'm so pleasure to have the opportunity to introduce you a new generation product which we will develop with Facebook. We call it Carmel. And welcome to the tour from the 21 to 19. Okay, let me introduce myself briefly. I'm Bill Lee, Mechanical Associate Director from Wiwynn Technology. And if you have any questions or if you want to have further discussion about Carmel, welcome to Wiwynn's booth, or you can check my email here. Boom. You'll find I used 15 pounds to prepare this presentation. Okay, why do we have this product? Open Compute Project proves its efficiency in energy consumption, reliability, and power saving, cost advantage for the data centers. But OCP also defines their own 21-inch Open Rack spec, which is different from the traditional 19-inch server and racks used in the traditional data centers. It means we should have much more investment and revolution to adapt to OCP 21-inch architecture. So, based on this condition, we start to think about whether we can have another approach to provide the product, combine the OCP's advantages with the 19-inch servers without big revolution. We've all seen the advantages of OCP Leopard motherboard, and it's a vanity-free design motherboard with great power efficiency and reliability. Today, I would like to introduce you another approach, which is Carmel. It accommodates OCP's motherboard and combined to their 19-inch servers. In the following, you can see the benefits when you choose Wiwynn's Carmel and its system architecture. And I will show you the options of 1U and 2U nodes and the Wiwynn's design characteristics. What can you benefit from Wiwynn's Carmel? Why do you choose our Carmel? First, power efficiency. Carmel uses the OCP vanity-free design motherboard with great power efficiency in an EIA 19-inch system. Second, better cooling efficiency. The font accessible motherboard nodes require minimal airflow and lower power consumption. Third, Carmel accommodates 4 sets high-performance motherboard nodes for our 2U 4-node configuration. And we also provide high flexibility on the request of PCIe cards and SSDs. Each 2U node supports 6-piece hot-swappable SSDs and 3-piece PCIe cards for our 2U 2-node configuration. Not only that, we always focus on the easy maintenance for the cost saving in the data centers. Server nodes and drivers maintenance are completely 100% hot-swappable and font serviceability with toolless design. In the cold I/O, just like OCP achieved this success. Okay, here you can see Carmel's system architecture. we all know the success of OCP's products with font accessible motherboard and hard drives. We also define our Carmels to be font accessible motherboard and hard drives. There are 2 optional motherboard nodes. For one U node, it accommodates OCP motherboard, and for a 2U node, we provide more flexibility on the PCIe cards and SSDs. On the other side, at the rear side, our system supports 2-piece redundant power supply and 4-piece dual rotor fans, which supports 7+1 rotor redundancy. How do you choose the proper configurations to fit your applications? If you are searching for high-density, compute-intensive applications, Type A, the 4-SAS 1U node is the best solution. Each 1U node accommodates one OCP motherboard with Intel dual-socket Xeon CPU, and it supports up to 145 watts. And with the OCP measuring card. If you are looking for high flexibility and the request on the PCIe card and the SSDs, you can choose our Type B with 2-SAS 2U nodes. Each 2U nodes supports up to 3-piece PCIe cards and 6-piece hot-swappable SSD. In the following, you can see more details about these 2 optional motherboard nodes. For our Type A 1U node, it accommodates Leopard motherboard with OCP's motherboard form factor. The motherboard supports Intel dual-socket Xeon CPU and 16-piece DDR4 DIMMs and the OCP measuring card. Furthermore, each 1U node also hosts one 4-high headlength PCIe card and one hot-swappable SSD. For our Type B 2 nodes, in addition to the same Leopard motherboard and the measuring card, each 2U node supports more flexibility on the PCIe card and SSDs. It supports up to 3-piece PCIe cards and 6-piece hot-swappable SSDs. Next, I would like to introduce you and discuss with you our Wiwynn design characteristics. First is our thermal optimization for power saving. No hardy array in front of our system to block the airflow. So the airflow impedance is lower and the cooling performance is higher. The PCIe and the SSDs are in the front, so there is no key component as the downstream of the CPU and preheated by the hot air from CPU. The heated air from CPU is exhausted directly. This design contributes to power saving. Wiwynn design is to minimize the heated airflow in front of the CPU and guide more fresh air into the mother node. Use the minimum airflow to cool down the maximum power usage. As you can see, left side is Wiwynn's Carmel architecture. There is no hard disk array in front of the CPU, and compared to the traditional high-density server with hard disk array in front of the CPU, Wiwynn's architecture and design enhances 30% cooling efficiency. Next is about the easy maintenance. We all see the Facebook success on the easy maintenance for cost saving in the data centers. Based on this fundamental of easy maintenance, we always focus on the design on it. So, first, our fans, PSUs, hard drives, and the multiple nodes are 100% completely hot-swappable. Next, follow up Facebook and OCP's design logistic and the benefits. The drives and the multiple nodes are form accessible and designed with tool lists. Do you remember how we install a traditional hard drive into our system? You may need an additional hard disk carrier, and then we should fix the hard drive with the carrier first by the screws. Then you can install each drive into the system. Today, you can throw it away. We come out with a new approach to propose to you. We use a linkage bar design concept. So you just need to push the bar, and the drive will be driven to be released and raised up. Then we can swap the drive very easily, and the hard drive serviceability is quicker and effortless. Finally, let me recap what you can get from Wiwynn's Carmel. Carmel integrates 4 sets high-performance OCP multiple nodes and EIA 19-inch system, and converges the OCP's benefits and the existing investment of data centers. Wiwynn's Carmel provides better power consumption and supports higher performance CPU and enhance the cooling efficiency. Furthermore, we always focus on the easy maintenance for the cost saving in the data centers. Our system supports 100% hot-swappable, and the design is trueless. Last but not least, our multiple nodes and the drives are form accessible in the core I/O, just like OCP achieved this success. This is all my presentation. If you have any questions or you want to have further discussion with me, welcome to our Wiwynn's booth. And I'm so pleased to have a chance to discuss with you. Thank you for your listening and attention. Thank you.
So an hour back, we had OCP come by and talk about their transition from 21 to 19, and they also talked about Carmel.
Yeah.
So is it a common architecture, or your Carmel is different from their Carmel?
Yeah, actually, the architecture of QCP and us is a little different. Yeah. Because the first one is our motherboard and our drive are from SS, and if you see the QCP's architecture, the motherboard and drives are on the rear side.
And so this is 1U, right? The one that you showed is 1U.
Yes, this is 1U node, but the system is 2U.
Sure. So each node is 1U or a half U?
Each node is 1U.
Okay, so that's a 2U.
Yes, 2U high, 2 high, yes.
Is this currently available to your vendors or for smaller level, 1 or 2 servers? Vendors, you mean to purchase the app, 1 or 2 servers, is that available?
Yeah, this product is under development and
the question from Jennon was when we can deliver sample, and this sample is this system is in PVT stage, so we can provide you the sample after we receive their order 4 to 6 weeks roughly, because there are components we need to purchase from the market. Any question for the design or risk?
Do you have a comparison on your density, the rack density?
Do you have a comparison with respect to the rack density for your Carmel-based 19-inch server rack to OCP 21-inch rack? Do you have the rack density number comparison?
Assuming they both are 1.
Yeah, there are different architectures, so it really depends on how what's the power I can deliver to the rack, the EI rack, because there's no power in the rack. And for OCP, it's the power shell itself attached to the rack. So what we can compare right now is the physical space, right? So if you take a 42U EIA rack, then maybe you need to switch, right? And then you have 40U, and 40U, then you will have 80 servers. That's the limitation from the real estate. But it also depends on what the cooling and also the power that you can support all the 80 servers.
It looks like you're building more density.
It depends on the infrastructure. Actually, if you can support that, then it can help rack up to 80.
It's the actual power indication. This is much denser. For 2U, you can have 4 nodes, and for OCP 2U, you can have 3 nodes, and their OCP is much more. And also, in addition, for the whole rack, this one doesn't need the power shell. And so, in addition to the power shell, pick up the power shell. Here, the power has no limitation, but there's power limitation.
Any further questions? Okay, so thank you everyone. If you have want to see the samples, Wiwynn booth is at C2. Welcome your visit. Thank you.
thank you.
Just gonna leave my stuff there. That's all.